tired, but now you got a coffee, so we can start now. So that we have some time for questions, I would like to introduce now to our second keynote speaker of today, Mark Brenner. So yesterday we had the talk of Jonathan Obrist, and he very nice said the way that you have helped lots of ECRs, including myself. Now I am mid-career scientist, but just like Jonathan, I can only be thankful of all the help that you have given. You know, like I still remember, Mark, I don't know, when I was like 20 or 21 or 18 years, I don't know, I was starting the university, and back then we didn't have like email, so you cannot really imagine how it was. And I got like this huge package of printed papers of Mark talking about paleolimnology and stable isotopes. And I guess during my biology studies, I only heard about ostracods, not even isotopes. So this opened, you know, like all the what already happened now, you know, like the rest is history. And he was the one showing me also like short course and saying like exactly in these centimeters you have when the classic Maya collapsed. And I remember I had like this chicken, you know, like piel de gallina, chicken skin, as we say in Spanish. And I said like, I want to do this for the rest of my life. So thank you, Mark, for helping everyone. And that's why we invited you. The title of your talk is going to be Recent Advances in Paleolimnology. And he's a very enthusiastic limnologist and paleolimnologist. He has worked a lot in Central America, but not only in these tropics, but also in the other part of the world. And I guess mostly you are interested in investigating the interaction between climate and humans. And so thank you, Mark, for being here. And the screen is yours. You can start sharing again.
Alrighty, let's see if we can do this. Can everybody see my screen?
Yes, perfect.
Very good. Well, first, I want to say a couple of words. I've really appreciated the previous speakers. Great work being done. And again, it makes me enthusiastic and very positive about the future of paleolimnology. Couple of things that I heard from all the keynotes is that they really enjoy the multidisciplinary aspect of paleolimnology, and I feel the same way. I think what is great about it is that I get to work with wonderful people. And in fact, when I reach out to ECRs, they're the people who are injecting new ideas right now and really helping my work so much. So I enjoy that interaction tremendously. I like the idea of sort of putting together funny stories from the field and the lab. I have at least 2 or 3 volumes full I could probably supply you with. In fact, I could have maybe done a different kind of presentation today. I'll just tell you one little story. In 2018, when we went to Guatemala, the quarry in Lake Amatitlan, we were very frustrated because our equipment didn't come out of customs. So we decided to pivot a little bit and collect some surface sediments with a dredge. And we dredged a baby diaper. I think that's a first, right? I don't know if anybody else has done that before. We didn't do any analyses on it, but I suspect it was used. Okay, so what I'm going to do today, I just want to talk to you about some of the advances. I think you're aware of many of these. What you're looking at here on the left side, that's Matt Waters with a mudwater interface core from Lake Chichancanab in central Yucatan, Mexico. We're preparing it for extrusion. What we do with these uppermost sediments, they're usually fairly unconsolidated. You can see these are nicely banded, but we extrude them vertically and take them off the top. On the right-hand side, you can see the deeper drives and overlap drives from that Chichancanab core. And in the middle there, this is about where we're setting up to go out on Lake Coba, another of the lakes, a fairly shallow lake by a very large archaeological site in Yucatan Peninsula. So I'm sure almost everyone is aware of the tracking environmental change using lake sediments volumes. These came out right at the beginning of the millennium, and they're really wonderful edited compilations of material about, as you can see, volume 1, basin analysis, coring, and chronological techniques. to the physical and geochemical methods, then the terrestrial, algal, and siliceous indicators. At the same time, volume 4, zoological indicators came out, and about a decade later, the volume on data handling and numerical techniques. And just this past year, a real breakthrough here, how to use sedimentary DNA to interpret the past. And I think this is really a sort of new breakthrough. And if we look at some of the other volumes that have come out, and I sort of picked the time period from the beginning of the millennium because it probably coincides with maybe the birth dates of many of the people who are attending today. So a lot of this has happened since you've been born. But on the left side, what might be arguably the best sort of course volume for a class in paleolimnology, Andy Cohen's book on the history and evolution of lake systems. Many of you may be aware of the fact that Andy passed away this year. Real loss. He was a star in the sense that he was working closely with ICDP, doing a lot of work on the Rift Lakes in Africa, and one of the people who really pioneered working with local communities. And we heard a little bit about that today in terms of the work being done in Ecuador and how important it is to work with local people. We see John Small and Sturmer's volume, the second edition of on diatoms, and then John's pollution of lakes and rivers. And of course, this is just a few of the sort of important volumes. I apologize for the fact that I could not find an image of Journal of Paleolimnology with the current editors listed on the cover. I think maybe that's because everything's gone electronic these days. But as many of you know, Tom Whitmore and I handled this for about 15 or 16 years. The current editors-in-chief are Margarita Caballero, Guangji Qian, Stefan Mishka, so from Mexico, China, and Iceland, a nice representation there. And I kind of want to use this as a time to plug the journal. So I encourage people to send your manuscripts to JOPL. They're always looking for good science. Obviously, one of the things about being in a multidisciplinary area is there are a whole host of other journals, and this is really just a smattering of those where you'll find paleolimnological information and studies, depending on whether the essence of it is more geological or biological. People will choose different journals. Obviously, some of them have built into the name things like quaternary or something like radiocarbon is pretty obvious in terms of what they're going to be dealing with. But again, I want to highlight JOPL and encourage people to send work there. Yesterday, I was impressed by Jonathan paddling his seismic equipment across the lake in Guatemala. And through the years, I think all of us have found ways to get the job done using low and high tech, ways of going about things. So from the top left here, this is a picture in 2023 of setting up the coring platform on a lake in Yucatan, sort of in the center top there. You can see Lisette over here, reclining on the coring rig going out to do Krulenberg coring on Lake Petén Itzá in northern Guatemala. On the right-hand upper site, a really high-tech coring platform there, pair of canoes with boards across them on Lake Coba in northeastern Yucatan. If we then come down, straight down here, you can see Jason Curtis holding a core from Lake Amatitlan. This is actually part of the pier that got towed out to the site and anchored at site. This is Jaime Escobar and Jason with a meter length of core from the Paramo in Colombia. A really interesting lake. Paddled around there looking for prospective areas to core. The whole lake was only about 50 centimeters deep, and we thought, boy, this is going to be a bust. And then we retrieved 7.2 meters of core. So a very nice record, Holocene record from that lake. And in the lower left here, this is the GLAD 800 drilling rig positioned on Lake Petenitsa in 2006, where we recovered about 1,300 meters of core from 7 sites. Most recently, I got my first experience in 2017 working out of what are called pirogues, or outrigger canoes, in Madagascar. You can see there's not a lot of workspace on the left-hand picture there, but these functioned perfectly. They were very stable. In the upper photo on the right there, these are often used actually in the coastal environment. And so this one was brought in by a zebu cart. You can see a pair of zebu as they're getting ready to take this boat back to the coastal area. So one of the things I just wanted to point out is that a lot of labs now are getting into making their own equipment. And Jason Curtis has been fabricating coring gear for us for many years. Over time, we have sort of learned how to do things a little bit better. On the top left here, you see a number of our old style pistons, which were basically 2 plugs put together with a bolt and then shaved down to have a flat surface against the tube. In the middle, you can sort of, middle photo there, you see the piston positioned at the base of a tube prior to getting ready to core. And you see a little pressure release valve there. In the upper right, you can see the coring heads for these mud-water interface cores. These are PVC. They now are attached, as you can see in the lower right, with sort of a clip here. And they have within them sort of these large threaded pieces that thread to either mag-zirc rods, magnesium zirconium rods, or now what Jason's making, carbon fiber rods. And we use either this Spectra cable, which is not metallic, or standard metal cables. One of the great things that Jason has developed, and I think he would say he stole this from the Swiss when he was visiting a Swiss laboratory. He took a picture of something they had and modified it somewhat, is this tripod that has a grease gun on it and basically takes these metal rods and raises them. So if there's an extruder piston here at the base of this core tube, it basically pushes the core up. And then at the top, you can have a tray to catch that material, and I'll show you that in a moment. These are some of Jason's carbon fiber rods. These are really superb for getting into remote areas because they weigh almost nothing. They're very lightweight, and he makes these in meter-long and meter-and-a-half long lengths. And finally, some of the coring heads and locking pistons for the deeper coring that has to be done after the mud-water interface cores are taken. And the idea here is when the drive is completed, this piston goes up into the head and locks in place so that even if you have a lot of suction, you're not going to lose core out of the bottom as you retrieve it. So here we are on the left-hand side, working in a lake, a shallow lake in Florida. Years ago, I built this blue box here for a study where we were incubating cores. There was a front on this thing, but we realized we should probably keep this because it's handy when we're out on a lake and taking multiple cores, just to set them in there till we get them to shore and can extrude them. Here's a core prepared now for extrusion. Here's the piston up at the top after the drive. There's an extruder piston down here. The thing that raises it is on the back side here. And what you can see on the left side is a tray for catching the sediment, the watery sediment that comes out. We can get it directly into cups, labeled cups, and seal them. These are pre-weighed, and then we can weigh the wet material and the dry material and get a dry mass per unit volume that way. On the right side, a core from a slightly different site in the lake and at depth of 32 to 36 centimeters. And at this point, we can just sort of cut these off with a knife or some kind of a spatula. And of course, these things break down. Jason has designed these to come apart. And here he is assembling the tripod. Here it is in action. You can see we were working, there was a guy doing some carpentry in the background, didn't really seem to care at all what we were up to. I was fascinated by what he was doing. building a table. There's the core in the back with the piston, about 15 or 20 centimeters of water above the mud-water interface. And now Jason's raising it up so that we can begin the job of sectioning it. Here we are on Lake Chichen Canab in Mexico. You're going to hear, I believe, from Savas, and he's going to be talking about some of his work in Florida. Savannah Wooten, they're both students at Auburn University in Alabama. There's Jason, and again, here's Matt. In all the photos of Matt, notice he's hiding his face there, so I think he's worried that AI was going to record his face, and who knows what that would involve. But here is one of our meter-long drives. Here you can see some of the nice banding in those cores. And this is another, again, this is Lake Coba, the lake you saw in the first picture. And one of the very nice things about coring with these polycarbonate tubes is that they're transparent. You can see immediately what you've retrieved. Here's Jason doing a little product placement here with his beer. And he's also, what he's doing is he's looking at about 6 meters of core and overlap core from a site in Lake Coba. This was a 2023 core. And what you can do very quickly is you can lay these out and sort of look at the banding pattern and see that you've gotten very complete drives and also have the overlaps. You can also establish this with using a multi-sensor core logger. And I don't know how many folks out there are using these. We have one. I probably should have taken a picture of ours before it was boxed up for use in a marine context. We went out on a ship, but we have a magnetic susceptibility loop. We do gamma density, although in ours we have this arrayed in a horizontal fashion. And what happens here is there's a cesium-137 source that goes through the core and a receiver on the back end then basically receives that gamma ray, and the more it's attenuated, the higher the density of the sediments. And of course, over time, because cesium has a fairly short half-life, this value is declining in the source, but this is very handy for doing quick density. Then we have a camera for doing imaging, and we have the core pusher over here. So mostly we use this for density, magnetic susceptibility, and core imaging. And I'll show you some really cool examples. This is basically a core from that same lake, but 10 years earlier, Lake Coba. What I've done in both cases here is I've compressed the core to show you how we can match up the original core drives. These are 1 meter long. This is 1 meter. And so it's very crunched in this direction. Here's the next meter down. And here's the overlap core, right? And here's another overlap. And you can see how beautifully these line up like this. And obviously, when you're coring down, there's probably going to be some missing material between these extracted meter-long segments. And so you can fill in with your overlap cores. Here, I've stretched these cores out. There's exactly the same image over here, but stretched out a little. And you can see how these match up very, very nicely. What you can also see, in a case like this, these are some 2016 cores from 2 sites in the same lake, Lake Coba. On the x-axis here, you go from the surface down to a little over 6 meters, and I sort of stretched these to match one another, top and bottom. These are 2 different sites in the lake density, and what we have in the upper one here is the original core. We start 50 centimeters down, so we take the mud-water interface, which goes to about 80. Then we usually start at 50 centimeters, go to 150, 150 to 250, 250 to 350. So that's the blue going down to about 550. Then we did an overlap core, and that goes from 1 to 2, 2 to 3, and so forth. Then when we run these through the core logger, you can see that they overlap pretty nicely. And of course, there are going to be a few flyer points, which you might expect, particularly in a core like this, where we're doing these at centimeter intervals, but we have this banding, and it's not going to be perfect. If we were to do like a 5-point running mean, these would probably lie over one another very, very nicely. We did the same thing down here with the green being the original core, going down almost 7 meters. And then we did some overlap coring, only down to about 5 meters here. But what's really cool is you can see that in these two different sites, if you sort of squint at these, we're recording the same pattern at the two sites. So we have both at a site overlap cores showing the same thing, and then across two sites, we can demonstrate that we have the same sort of picture. There have been tremendous advances in dating. Really lead to 10 dating only goes back to 1963 when Goldberg conceived it. Our early attempts at dating dealt with alpha counting. Here, Mike Binford was doing a lot of that in the 80s, looking at some of the acid rain studies. These are 3 of 4 gamma detectors we have in our facility now. And there's also been great advances in stable isotope work. If we go back and look at some of the work from the late 1960s and early 70s, people were doing a sample like every 500 years in cores because it was so time consuming to get data. Now we are routinely doing like 1 centimeter and smaller intervals. Many of our cores have 700-800 data points in them. So we're getting very high resolution data out of some of these cores. This is Jason Curtis's lab here, and I'll just kind of show you a list. This will be up there for you to look at in greater detail, and there's a website at the bottom if you're curious about the kinds of things that can be done. But I just show you some of that equipment in close-up. So on the left-hand side here, you see the Kiel carbonate device for delta C13 and delta 18. This is used routinely on snail shells, bulk carbonates, ostracods, and so forth. The TCEA here on the right side for delta D and delta 018, and the delta V plus mass spectrometer, which is doing the mass spectrometry. Here's an old workhorse here, a Carlo Urba CNS analyzer connected to a delta V advantage here. So what we do here is look at particularly carbon, nitrogen, and sulfur percentages in solids, but also the delta C13 and delta N15. So these prep systems are basically designed to convert those solids into gas form to then enter into the mass spectrometers. Jumped ahead there. Here's a Costec instrument, elemental analyzer for CNN percents, and then sort of a duplicate of what you saw a moment ago with an analyzer doing carbon, nitrogen, hydrogen, sulfur, oxygen, and then able to do delta C13 and delta N15 in solid samples. And this is just one example of data. I'm not going data heavy here. This is our 1995 Nature paper from Lake Chichen-Kanab about an 8,000 year record. These are radiocarbon years, not calibrated. And this goes back to the talk we just heard a little bit ago about standardizing. It's very difficult because people were dating different materials, especially prior to AMS, when people couldn't focus in carbonate regions on terrestrial organic remains and so forth. But in any case, what this is showing, if we look at the calcium carbonate amount here, coming up over the last 8,000 years, this is the sulfur, and really this is gypsum. This is the delta 018 on ostracods and the delta 018 on gastropods. And we cored essentially through the lake sediment in this lake. The earliest sediments here are characterized by a lot of gypsum and very high values for delta 018 in the gastropods, the snails, and the ostracods. Very soon after the lake fills with water, things are much wetter here. We see the delta 018 values decline here in both cases in the snails and the ostracods. We see this 4-aminopterin, ammonia beckeri, disappear. This is an organism that likes fairly saline conditions. And then we see fresher conditions throughout about 4,000 years or so of the Middle Holocene. And then about 3,000 years ago, we see deposition once again of gypsum Here we see the onset of drier conditions, which is responsible for that gypsum precipitation, and then kind of extreme conditions at this red line, which corresponded to archaeologically this huge demographic decline for the ancient Maya. So this is what suggested to us that severe drought, and as we found out later, looking at higher resolution at this period of time in other cores, there was actually a series of droughts that probably contributed to this demographic decline. So the last sort of piece of equipment from Jason's lab is this Picaro instrument for water analysis, very rapid water analysis. It's not an isotope ratio mass spectrometer, it's a ring down instrument, but you can actually take these to the field. They're pretty rugged, but is for doing delta D and delta O18 in waters. And then again, some of Jason's own design. This is his Automate prep device. This is for doing percent TIC, or total inorganic carbon, in solids, so in carbonates, and also dissolved inorganic carbon in waters. And what it consists of is basically a sample tray here to which acid is added to generate CO2. And on this side, you have a UIC coulometrics coulometer. It's a kind of colorimetric method to detect the amount of CO2 that gets dissolved in this material, in this fluid down here. So you can talk to Jason too about that. We also have another dedicated lab, and this one is run by George Kamenov for the heavier elements, the ICP-MS, for heavy element concentrations, things like lead, potassium, things of that nature. So, and also for doing isotopes. And so we're doing strontium isotopes, lead isotopes, and things of that nature. And we can do that in liquids, so people do digestates, but also George does this in applications of rock and so forth, where he can use laser to ablate the samples and turn them into gases and measure the isotopes in those. And we have a pair of these, an older machine and a newer machine. I think one of the things that attracted Matt Waters, who works with pigments, to Lake Amatitlan, which you see a map of on the left. And the lake actually is, the outline is here. What was so attractive, of course, was the beautiful water in the lake, which is often hosting these massive microcystis blooms. Even in this photograph here, you can see that this basin has a bloom on it. And what happens here, of course, is water passes down a river here, enters the lake here after picking up a lot of nutrient and other things. The water enters here, it actually exits over here. And we, in year 2000, went to this lake and sort of prospected for good core sites. There were about 3 good sites, but this is a site we've returned to on a number of occasions. That's not where we got the diaper. So if you're looking for diapers, don't bother going back to that site. But what was really amazing about this core, which is a fairly long core, but only represents a little over 2,000 years of sedimentation, is that evidently this lake has hosted these cyanobacterial blooms for a considerable period of time, and is probably, these periods where you see these large amounts of canthaxanthin, aphanizophil, and echinenome are associated with periods when there were many people living in that drainage basin. Many of the values up at the very top actually go off scale. Echinenome wasn't measured up in this surface part. But what's really cool about this is that Matt was able to directly measure the cyanotoxins in the sediments. And this has been an issue, a potential problem for quite some time. So if there's a take home here, it's like, don't eat any fish out of this lake, okay? So as we go forward, when we were there in 2023, we hit 4 lakes, 2 of which we had gone to before, 2 of which were new. there are, I think, some interesting questions that we'll address here. On the left-hand side, there's actually a lot of ranch land around this lake now, but also on the right-hand side at Scotch, there are ruins nearby, and the lake is hyper-eutrophic today. There are also cattle in these areas, and I think this might be a really cool place where we could apply some ancient DNA to address the timing of when cattle ranching started there. The other thing that we found was both here and in Coba, there are enormously high levels of mercury at times in the lake cores, and Matt's working on that now. We're suspecting that people were bringing cinnabar into these areas, possibly to coat burials, people who were buried, but also maybe just to coat their buildings and paint them in the beautiful red colors that we know existed there. There are other places, like in Madagascar, where you see pretty striking evidence of these pigments. Like this is probably Halobacterium salinarum, which is very typical in saline systems. And again, a sort of funny anecdote here, when right before we went to Madagascar, we were talking to the archaeologists who had invited us, and really one of their interests at Madagascar was the timing of the peopling of the island. So Madagascar is the fourth largest island in the world, and although it lies off the coast of Africa, the east coast of Africa, it was actually peopled by people from the east, right? So the Malagasy language actually comes from the sort of Australasian area. And while we were discussing this with the archaeologists, they kept saying, and what we're going to send some, the geneticists here are going to send DNA with you, because the idea was we're going to take these cores and they're going to look for human DNA if we could get cores that were long enough, because there's a big debate about when the peopling of the island occurred. And we're going to send DNA, they kept saying. We're going to send some DNA with you. Finally, I said, hey, wait, whoa. I'm not crossing any international borders with a big jar of something that says DNA. You gotta fill us in. They said, okay, here we'll arrange a meeting with some of the people there in genetics. And it turned out what they were going to do is give us capsules of jellyfish DNA. And the idea was that each time we took a core section, we would mix up some of this jellyfish DNA with water from the lake, and we pour it into our core tubes on our piston and so forth. We'd then collect the sample, we'd seal those samples up, and later, when they went into the center of these cores to pull DNA, if they came up with jellyfish DNA, they would know that there was contamination. So it was basically just a tracer to figure out whether the interior had been contaminated. Well, sadly, our cores, none of them went back far enough, really, I think, to address the question of the peopling, but we got a lot of very cool paleoclimate data out of that. So again, I just picked a few examples of some really, I think, stellar work that is using ancient DNA. The one on the top left there is sort of a review article. Now it's, about 8 years old, but it's a really handy article to see what some of the capabilities are. As I mentioned, the new volume of tracking environmental change also addresses the use of DNA. And I think on the lower right there, Kurt Steger's study was addressing a question about whether perch, a type of fish that he was looking at in Adirondack lakes, whether they were natives or invasives then, because there was a lot of assumption that if, the perch were coming into lakes and eliminating other fish in lakes. And in one of the studies, they were able to show that no, perch actually had been in these lakes long before people arrived there. So again, from some of the things I heard from the keynotes yesterday, I think all of us share this love of getting out in the field with our colleagues and meeting people from other cultures. And I think that has, been one of the sort of driving forces for me too. So I have on my wall in my office an album cover from the Swiss band Yellow. And the title of that album was called "You Gotta Say Yes to Another Excess." And whenever somebody would call me up and say, would you be willing to like go to Peru next week or do you think you'd have time this spring to go to, I always look up at that album cover and I go, yeah, you got to say yes to another Access. When do we leave? But anyway, my experiences in travel, into other cultures, in other countries have really been fabulous. I've found the people in those countries to be super friendly everywhere. It's been super positive, whether it be in, previous picture Madagascar or Yucatan, where I've returned many, many times. And in many cases, like on the right side, the family you see there, we've gone to visit them numerous times in the past. On the left-hand side, China. On the right-hand side, a picture from Cambodia in a really remote area of the big lake there, Tonle Sap. And you can't see it in this picture. I have another picture of this, but this little kid over here, this little 2-year-old, had a Britney Spears T-shirt on. And again, that sort of told me a lot about globalization. I'm not sure I share exactly her enthusiasm for Britney as an artist, but it was cool. The other thing is, people are talking about trajectories career-wise. Well, my undergraduate degree is in biology. My graduate degrees are in zoology, and I'm in a geology department. But I still have this, sort of passion for wildlife, and I thought I was going to be a herpetologist. On the left-hand side, you see this is in Yucatan, one of the largest colonies of pink flamingos, Phenacopterus ruber. And on the right-hand side, there's actually a photograph taken by one of the students I took to Yucatan using a GoPro. This is a small Morlet's crocodile that was in Lake Coba, but close up. Also in Yucatan, you bump up against many of the iguanas. They're ubiquitous there, and also the red rump tarantula. They're the ones that keep your houses free of cockroaches and things like that. So they're appreciated. The other thing is you get to eat all kinds of wonderful cuisine. I see Paula and Lisette already thinking about what they want to order up when they go to Yucatan next month. Also, as they both know, and Julieta knows, I'm a great fan of alternative music, and there's lots of different musical styles that one encounters wherever one goes, from the sort of typical trio on the left to alternative bands like Gran Marquise. And one of the nice things too about working with ECRs is that they're very adaptable. At the end of the day, you just like hang them up. And so you see Gabi Alfaro. This was during our drilling expedition in 2006. And Lisette on the right-hand side, they were working 12-hour shifts. So this was very well-deserved downtime. The other thing is, again, when we heard about landscape earlier today and waterscape and what it means to local people, and there's a growing literature on that. Certainly for those of us who work in the field, there's a great feeling that, landscape is meaningful, and just the beauty of these places is super important. And with that, I'll end and entertain questions or comments if people have them. Thank you.
Thank you very much, Mark, for this great presentation. I guess everyone really liked it. Well, I really liked it, everything you found, you were showing. So questions. We have enough time for some questions, I guess. Rodrigo, it's the first one. So we cannot hear you, Rodrigo. We cannot hear you.
I think
Now,
you're muted.
Now, maybe? Let's see.
now, can you hear me?
Yes.
Can you hear me good? Yes?
Mm-hmm.
Okay. Yeah, now. My internet is a little bit slow today. I don't know. And Mark, nice to see you. It's always
Good to
nice
see you.
see
Yeah.
And it's incredible what you have shown. And my question is, you have been in paleolimnology like for decades, and you are like a legend for me. So what is your opinion? How do you see the paleolimnology like in 10 or 20 years? Which paths or which direction the early careers should follow in the following years? And which topics do you think are like important to address?
Yeah. it's hard to predict because I think the pace of the accelerated pace of new techniques, technologies is really opening up all kinds of new possibilities. So I think DNA is going to be something really important. I think looking at heavy metal pollution and things like PFAS, right, and plastics, microplastics, is an area that is probably going to receive a lot of attention. Maybe pharmaceuticals too, as we go forward, because we're developing these capabilities now to see all kinds of hormone analogs and things like caffeine in sediments. And I don't think there will be, an end to this dramatic interest in paleoclimate, because also with new drilling capabilities, we'll be able to go to different parts of the globe and get these very long records that have high resolution, sort of paleo rainfall, paleo temperature records and things like that. I would, I guess, just advise people to actually pursue the questions that they're passionate about. It's hard to predict how the wind is going to blow in terms of topics, but please, just do the things that really get you excited. And as I say, I really feel like I'm so lucky that I am approached periodically by early career people who have so many great ideas and kind of sort of force me to try to keep up with them. So that is really very helpful. I greatly appreciate it.
Thank you, Mark. Thank you, Rodrigo. Fernanda?
Yeah. Hi, Mark. So, my question is, if you could give us an advice to those that we doesn't have too many experience as you, how we could face with this strange era that we are facing with negationism, people who doesn't believe in climate change or even in science. What should be your advice or the key words that we could have in mind to face this new future that seems in front of us?
Yeah, that's a difficult question. I guess what I would say is this too will pass. When I first got in the game, as I explained earlier, I came in at a time in the mid 70s as a student, and I didn't really even know, I never knew what paleolimnology was. This was something I sort of landed in accidentally. I thought I was going to go into reptile and amphibian population genetics, and I still love that stuff too. So at the time when I came in, some of the big questions were about acid rain, yeah, and eutrophication. I would say those were sort of the two biggies. And I think if you look at like John Small's career, he got involved in the acid rain work with diatoms, and that was like a huge, shot in the arm for diatom taxonomy. People began to work these things out. I think, again, there are climate change doubters that will go away. I think a lot of people are on board with climate change, and you never know how the politics are going to go as we go forward. And sadly, even today, one of our speakers couldn't be here in person because of these terrible things that are going on around the country. And I have to apologize that I will miss some of the later talks today because I'm going to translate for a person who's here as a refugee and is seeking sort of more permanent status. So I'll apologize now for doing that. But again, I would say, stick with what you love, figure out ways that you can, be adaptive, pivot to work with other people, extend your contacts, stay in touch with as many people as you possibly can, let them know that you're looking. A lot of times things come up and, sadly people are unaware of possibilities beyond just the academic track. We're also explaining to many of our graduate students about possibilities in state and federal agencies. Again, some of those right now are not looking so pretty. So I have a former grad student who went to our Environmental Protection Agency, and she's really great. She was working on heavy metals in lakes and has worked at EPA in that. And, you know, who knows what her fate will be in the near future, but certainly she's developed so many skills while there and while here as a student that I think, you know, she'll be able to work in related areas and be satisfied, do satisfying research. So again, I would say, you know, do the very best you can to keep a hand in. And if you go out, somebody mentioned, I think it was maybe Martha mentioned, that Jonathan Obrist is the guy who started out after grad school, went into the private sector in oil, and then came back into academia. And sometimes that does happen. In some areas, that's actually valued tremendously, because the kinds of information that you gather while working in the private sector is helpful to graduate students, because you can guide them going forward to what the opportunities might be there. So I don't know if that helps. I feel the pain that everybody's feeling today. Believe me, you know, we have a lot of these discussions around the table, and it's harsh. I will tell you one thing though, just to put it in perspective. So I think many of you know Mike Binford, and I'll stop here in a minute because I know we're getting late. But when he was a postdoc, and I think it was about the time I finished, you know, we worked together, and he applied for a job here in the United States at a place that was advertising for a kind of a general ecology position. They had 410 applicants. Many of the people who applied were already in tenured positions or tenure track positions. Many of them had many years of postdoc experience. And so it was like, you know, very deflating to see the, you know, level of competition that was out there. And, you know, to this day, whenever I've been on enough search committees and I've run search committees, you know, it's harsh when you see 50, 80 applicants. Of course, a lot of those people are just trying to shoehorn themselves in. They're, you know, not really appropriate for the position, so it may not be as bad as you truly think. But again, I would say it's important to go to meetings, interact as much as possible, particularly so that when your application appears and people on the committee, the search committee, say, oh yeah, I remember that person. I met her at AGU. Really great talk, you know, or I met that person at the IPA, and wow, you know, knocked me out. Really good chat. So yeah, just keep publishing, keep developing connections, get out there, be visible, and, you know, then hope for the best.
Thank you, Mark. I guess those were like the perfect words to finish this first or second keynote. Thank you for your advices. We're really grateful. And yes, so see you in Yucatan in some weeks.
Okay, and I'll stick around a little bit. Then I have to go early today, but I'll see you all tomorrow.
And thank you for all the efforts in the chat. Some people were writing. Maybe you can still read the comments that they did. And thank you again, Mark. So now we're going to continue to the last